stuff. Okay, so what we plan to do today, we plan to discuss things related to technical track compute. Compute is a very important aspect of anything you build. I don't expect that any service or any application which is built will not be requiring a compute power. So we will talk about that. Networking track, I'll use the word hold the door here. We will discuss about NICL and security group. Just a quick checking here. Uh, Anyone knows what is the origin of this word? Anyone of a fan for some of the fantasy series? Anyone seen that hold the door? It is something which you might have seen somewhere. Anyone? Anywhere you have heard about it? Hold the door. Yeah, yeah, GOT, Game of Thrones. Yeah, exactly, Junior. So yeah, that's why I just told that thing from there, and we will do the same thing. We will hold the door, Hodor. Yeah, exactly. So yeah, just a little bit of pun intended. Let's move forward, and then we will talk about hands-on when Jamila would take over, and she would talk about creating and connect to your instances and some more stuff. Now, the activities we are planning something which you could follow on your own, right? But if there are some any additional things which you need, just let us know, and we would be happy to accommodate those two. So let me get started with the first technical track here, which is my compute in the cloud. If you remember what we discussed so far, we discussed about global infrastructure. We talked about foundational services, some of them networking and storage. Networking is the full track. We will discuss that. And then we will be then having platform services also on top of it. So what we discussed so far is storage. Networking is already a track which we are discussing and we'll discuss more. And today we will be focusing on the content of the compute part. Let me read one comment here. If you can share resource in advance for participant to go through, will help everyone to go through those in advance and ask many questions to clear this doubt. I like that idea, Harikishan. So let's see what we can do. So yeah, we will try. I'll see what can be done on that, but most probably it may not be giving you enough time, maybe just one day, because I have my schedule for creating this content is on Thursday. So on Thursday I create a content and then on Saturday we present it. So maybe one day, but we'll try to give you some heads up here so that you can be little more prepared. So yes, that is a good idea. I'll do that. Okay, good. Let me check one more question before we move forward. In S3 workshop, I have output curl, S3 next initialization, security, context failed, unknown error, and can't find a solution. I'm not sure what it would have happened, but ping Prasad on LinkedIn, and probably he would have idea on that. Or if he can't respond, maybe he's busy. Give him a day or two. If not, then let me know, and I'll try to look into it. What could have happened, and we can think about a solution on that. Yeah, this is a feedback we need, right? So keep on giving this feedback and that would improve and everyone would get benefited out of all these things. All right, thank you. Let's move forward and talk about compute here. Now, what is your understanding of compute? When you hear a word compute, what do you think about it? Anyone? What is your thinking about compute? What is compute? What is your understanding when I say compute? What is this compute? CPU, yes. EC2. EC2 is one form of compute processing. That makes sense that we want to ensure that we want to perform some processing. Now, when we say processing, it doesn't always mean that it has to be CPU. What if we need network power, right? What if we need some processing to be done in memory? So yes, any processor processing data, manipulate data, exactly. So this is what we are all looking for. Computers, where it is a general term, anywhere we need to execute something, and that execution may require some resources. So we are planning here that how we could utilize some resources and add some resources so that we can provide some processing power. So to calculate and answer an amount by using a machine memory processor, yes. So I would say compute is a generic term used for referencing processing power, memory, networking, storage, and other required resources. What I mean by other required resources? What if you are doing a graphical processing and you need a GPU, graphical processing unit for it, right? So that is also a compute, something which allows you to to break down your complex algorithms or program and then calculate the result and delivers the value, and it could be automatically will be provided by CPU, memory, networking, storage, and maybe additional things like we have GPUs, right? Like if we will talk about maybe in machine learning chapters, what happens that even you could have a GPU associated to your servers just for machine learning inferences, and once that inferences are removed or done, you could remove that GPU and run your machine like a standard machine. So those type of capability which enhances your capabilities to process something, whether it is in terms of memory, network, storage, or any other resource, that is what we would be considering as a compute. Now, these resources can be physical or virtual, right? Makes sense. Initially, we were all using physical resources, but nowadays, I would say most of the resources are virtually provisioned. Ranga says number crunching. Yes, that is another good thing. Yeah, we were doing this. Initially, computers were designed to do number crunching instead of running lengthy algorithms and doing manual processes. Probably calculator was initially invented for that, and then a big brother of calculator is somehow is a computer in a way, right? Now, physical servers have their own challenges. In a physical or traditional approach, what we do, we run physical servers, we rack them, stack them, power them, cool them, and then we have an operating system of our choice, and on top of it then we run our applications, right? And once application is ready, I would be able to access this server. But the challenge of this is a traditional approach, and industry average utilization of the server is 5 to 10%. Now, what is happening here that over a period of time our servers are becoming powerful and powerful, right? I remember my first computer which I bought was a 120 megahertz Pentium processor, Intel Pentium, and I was very proud because that time only 100 megahertz processors were common, and I have worked very hard, talked to a lot of people to get a 120 megahertz processor. And if I'm talking about this specific megahertz today, I would say any basic electronics you pick up, it would have more than that capability. So what is happening over a period of time that my servers are becoming powerful and powerful, multi-core processor, lot of RAM available inside it, and that's where challenge is my application may not be able to utilize the full power of that particular hardware which I am providing, and servers are coming with dual CPU, multi-core, and then multiple RAM slots inside. So lot of resource is getting wasted in that case. So what is happening? My average server utilization is just remaining 5 to 10%. Think of it like you bought a house which has 20 rooms inside, and you are just one single person. You are just staying into this particular place, and that's how you are utilizing that, right? So that can be one challenging thing because we have just wasted this much of money or this much of resources, which is not at all good for any business or anything, right? All right, good. Ranga says their computer was 166 4 KB RAM, 16 MB RAM. Yeah, no, not even 16 MB, 20 MB hard disk. Looks funny now. I agree. I agree on that. 1992. Good. So, so this is my traditional approach of servers. Now, what we do now, we have a virtualization based approach. We take the same physical server. On top of it, we run Hypervisor. It is a kind of operating system, but it is fine tuned to run on on a specific set of hardware and virtualize your hardware, and that allows me to create a virtual machine. So this virtualization approach virtualizes the hardware like CPU, memory, disk, and network, and it creates a virtual machine resources or virtual resources. On top of it, I can run my operating system, I can run my application, and I can have multiple virtual machines running like that. The example I take to explain this basic concept related to virtualization is think of that you have a piece of land, and on that piece of land, you could say, hey, I would be building one house and one family would be living into it. That is one option. Or on this piece of land, I could build a multi-story building, and in that multi-story building, there would be multiple families living, and that's how I am best utilizing the resources I have. So piece of land is same, that is your server, and then depending on what type of constructions you do, either you will accommodate one family, which is your traditional approach, or you would accommodate multiple families or multiple virtual machines inside. That is your virtualization based approach. So hopefully this would be giving you a better idea on that. Now, what made virtualization possible? I would say because of the powerful machine, we have so much CPU, so much RAM available that we could run multiple virtual machines on top of it. That's why virtualization has given way to this approach, and we are utilizing now a better server, like 70 to 80% utilization is very common on that. Right. So virtual machine, I could refer them as a digital version of a physical computer. You could call it like a software based computer, or a computer implemented into software, a server running into software. So that is a virtual machine. And a virtual machine can perform all the same function as a physical computer, including running application and operating system. So that can be done. Obviously you can't kick a virtual machine. Like sometime when your servers were there into the server room and they were making a lot of noises, like in the sense the fan was not performing as expected, you would give a gentle tap and it will work. You can't do that with virtual machine. But other than that, most of the operation which are there with a physical machine can be performed in a virtual machine too. And as this is a virtual machine running a full blown operating system, you would still have to perform maintenance operation like update or system monitoring. So that would also still be required. So that is what a virtual machine is. Any questions here so far? Anyone not following along? Anything which is not clear? Maybe for some of you it will be very basic, but yeah, I want to ensure that everyone is on the same level, and then we can utilize it, right? But also virtual machine is not making noises. I agree on that. I agree on that. So that is true. Yeah. So just you can't kick them, but yeah, they are not making noises. So that is much better, right? Good. Now let's move forward. Now, uh, how Amazon runs this service. So in Amazon world, this one is referred as Amazon Compute Elastic Compute Cloud, or EC2. We love this word elastic in Amazon: elastic compute, elastic load balancer, elastic map reduce, elastic IP, lots and elastic network interfaces. So elastic is a flexibility which is being given to you. That is my EC2. And the service calls itself a virtual server in a cloud. We could utilize a virtualization server. So in a traditional world, you would take hypervisor from companies like VMware, Hyper-V, Oracle VM, and then we would be running virtual machine on top of it. Now AWS is running EC2s from, I believe, 2006 onwards. So in this all days or all these years, AWS has perfected the way that what would be the best way to run your application and run your EC2 machine. So AWS has built their own system, which is called Nitro. Check for the more detail about this Nitro system. This is a good evolutionary hardware which is made up of software hardware component. Security is also built into that, and that is a purpose built hardware software. If we have taken a traditional server from the market, maybe a lot of that feature may not be needed for us. So what we did, we have created our own custom hardware software combination that we call Nitro, and probably when you launch a new instance, it would be running into a Nitro system. So that's what we are trying to do here. And once this hardware software is ready, on top of it, I could run an instance which will have operating system, which will have application, and obviously I could run multiple instances if the need be. So the service is called Amazon EC2, and the resources which you create inside that is called your Amazon EC2 instances. Now we use the word very interchangeably. We sometimes say we have a EC2 machine, we just say we have an instance, we say we have virtual server, but these are all referencing to the same type of compute resource by which we could provide the running capacity to my application. So that's what is a virtual machine. All right. And running these virtual machine in AWS is very easy. I'll quickly go to console and start running a virtual machine there so that you could understand what I'm planning to do. So I'm logging into console and I would be looking for a hosting of a web server. Let's complete and create a web server so that we can utilize it for some application running or whatever. Could you explain the different type of hypervisor? Uh, okay, give me a minute. Give me a minute. That is a question here. I would say there are two type of hypervisors. Let me draw that. Okay, so I would say, let me clear and type this again. Give me a minute. I would say there is something called type 1 and there is something called type 2 hypervisor, or this is called bare metal hypervisors, or these are called your um, just standard OS level hypervisor, or this is the best word here is called hosted hypervisor. Let me explain the differences between them. Bare metal says that, hey, give me a physical server, and then you would directly install the hypervisor layer on top of it. So this is my physical server at the backend, and what I have to do, give me a minute, my yeah, color changing. So this one is your hypervisor here itself, and this one is your hardware, the server. This one is referred as a bare metal hypervisor, means directly on the metal, directly on the hardware you are running it. That is one approach. Second approach says, okay, let me have my hardware, let me have its own operating system, which could be Windows, which could be Linux or Solaris, whatever you prefer, a traditional operating system. And then I would install the hypervisor as an application here. So that is a hosted hypervisor. It is being hosted on top of an operating system. So in a traditional hypervisor, the bare metal hypervisor, anyone knows the name, probably you have heard about things like VMware has something called vSphere, that is your hypervisor which runs directly on the metal. Then Microsoft has their Hyper-V, which runs directly on top of it. Oracle has its own hardware software which you could run on. And when it comes to hosted hypervisor, in a hosted hypervisor, you would find products like VMware Workstation, which will be running on a Windows machine. Then you may have things like virtual desktop from Microsoft. So these are referred as your hosted or type 2 hypervisors, right? So depends on your use case. Now the challenge here is that in this case, your operating system is treating hypervisor as one single application, and it may not be giving the all the required performance or the control to the hypervisor because it is being treated as an application. Whereas in this case, this hypervisor has a complete control of the hardware. It knows how to utilize the best possible way, it knows best possible ways to utilize this hardware. So performance wise, it would be giving you better performance, because in this case what is also happening, when you have a operating system running, let's say on this hypervisor, now I deploy a VM and it has an operating system. So its request has to go here to this hypervisor software. This hypervisor software will talk to operating system, and then operating system will get it sorted by the hardware. But in this case, if my virtual machine is running here, it has its operating system, it can directly go and access these services. So that is much faster depending on how we want to configure that. So that are the two type of hypervisor: bare metal and hosted. Okay, clear. I hope this one is clear and you have a better idea on how all these things work. Let's see, then move forward. Hopefully that answers your question. And if you get your question answered, let me know. Thank you. Thanks for confirming. Okay, so I am on AWS console and I am on a Oregon region. And let's say I have to deploy a EC2 instance. So I will go to the service EC2. This is a AWS management console, not a very complicated stuff, just a UI by which we are accessing AWS services. And here I have something called EC2 dashboard. So EC2 dashboard would give me idea on what is currently available or running in my Oregon region in terms of EC2. So I don't see anything as of now running here. Everything is zero. Just I have some security group. We would go ahead and then discuss about creating something called an instance. So I'm on an instance page, and here I would be deploying an instance. My requirement is very simple. I want to deploy a web server, and in that web server, I would be hosting a page. That's all. I don't want to put a lot of complicated stuff here. So just a simple web server which I want to start. Let's go ahead and talk about launching an instance. This is a wizard driven process which I'm doing. But if I want, I could do the similar stuff through command line also, should not be a problem at all. So I'm launching an instance and it is a wizard driven process. I would specify some basic information. And once this information has been added, we should be able to create an instance. Right? So I would need to give it a name, and I think my web server is not a bad name. right? So let me use that name as it is. I would be then selecting different operating system level information. This is referred as AMI, Amazon Machine Image. Amazon Machine Image is basically a template which has some common operating system and application installed, which can serve as a base image for you to get started. Right. So you would have a base image, and through that base image, you would be then deploying a operating system. These are maintained by AWS. See this, these are quick start. So this quick start are giving you some commonly used operating system images like Windows and Red Hat, and it may not just have operating system, but let's say if I select Windows, here I could select a Windows 2022 base image, or if I look here, I may be able to find image with additional software installed on that, like we have SQL Server here, we have a base here, we have Visual Studio Enterprise, we have Office Professional Plus. So you could decide on what works well for you, and you can get started from there, right? So these are called my AMIs, Amazon Machine Image. You could use quick start AMIs if you want to, no problem at all on that. Or you could go ahead and say, hey, these are not serving my purpose, I need something else. So these are the four categories of AMI you could select from. Quick start, commonly used AMIs, 47 available. My AMIs, this is something which I created. So those will be displayed to me here. If I have something created, I would be seeing them here. Marketplace is something trusted by AWS and third party AMI. So AWS will be working with different providers. Let's say I am looking for something like I am looking for some DevOps tool, so I could select it, and I would be able to pick up some software which has been made available by companies like WordPress, Kali Linux, Palo Alto. So these are my marketplace AMI, which is ensuring we are utilizing something which has been provided by a vendor to get started faster. Question from Rahul: is there a specific way resource to learn CLI? Yeah, I will talk about that. We will like, address that. So maybe I'll have one lecture one day just to talk about CLI, because yeah, that can be very interesting for a lot of people. So good thing, Rahul. I'll see what can be done for that. So that is marketplace, and then there is a community AMI. So community AMI ensures that we are able to access something which has been published by anyone. I feel that some things are common and people use it very frequently. So as a community service, I could create a AMI and make it available to public. One reason here that I may not trust community AMI directly because they are not verified by AWS. AWS allows anyone to publish it. It is like a Git repository. So we expect people would be responsible and would be keeping things secure, but it may happen that some of the things which we have selected from here, we may not be able to get them patched, or maybe they are running an older version, or there is some vulnerabilities inside. So that may happen. So I may stay away from community. I'm not saying I should not be using it, but I would say if there is a quick start AMI available, I would prefer that because it would give me the latest updated version maintained by AWS. Now, when I say maintained, it doesn't mean that new patches will automatically get deployed in my application. Right? Now, what would happen in this case that I would be deploying something today which is from the latest version of that operating system, but if the new features come in, then I would be responsible to maintain those features within my application. It will not be automatically done, right? Question from Firefix: is all marketplace IMS free, AMI is free? Answer is no on that. It depends, I would say. So some vendors here may give you free AMIs, right? And once you start using it, maybe they will give you a trial. They would give you a license code for a while, and then you may have to pay for it. So not all of them. It would probably would have some cost associated. See this here, I could select free trial. So this is like free trial available on these products, but not other products. So it depends. Only 1153 are free trial. Others I may have to pay for them. So it depends. It's not a straightforward answer. It depends on who has published that AMI and what is the use case for them. So I could have selected that. Right. So I'm keeping it quick start. I'm selecting Amazon Linux, and here if you see there are two options. One says 64-bit x86. x86 is representing your Intel based processor and AMD based processor. x86 architecture is commonly used to run your is referred as Intel and AMD based processor, whereas 64-bit ARM, which is Amazon's own brand of CPU called Graviton, and we could launch from here too, and it would be much cheaper for me to run. It doesn't change the operating system, but it changed the AMI used on that. See this. So if I use 64-bit ARM, it would deploy AMI with the number 05 something. And if I use 64-bit x86, it would be deploying this AMI because the drivers in the operating system would be different. And that's why I have to select whatever works well for me. Right. So I have selected that, done. Very basic thing. And we will see what else can be done on that. So I selected my AMI, and then I would keep on moving forward and deploy some additional stuff on that. So see this. So AMI is selected, free tier eligible, verified provider. If you are doing these things in your personal account, be aware that you should select free tier eligible. And here in instance type also, you should select a free tier eligible instance. Right. So this is my instance C6.medium. These instances have a specific naming convention. So these instances will give you specific power performance in terms of CPU and memory, and you could have selected different type of instances here. You could see the list is up to 624 instances. This list can be smaller or larger depending on which region you are launching your instances on. So it depends. And here you could see that I could go up to a CPU of 448. I could have this much amount of memory, and this is again a huge number, 0.5 GB of memory, or if I want 18 terabyte of memory, right? Not even some people, we would have a hard disk in our laptop of 18 terabyte, but this kind of machines are available. So it depends on what your use case are. But my use case is to just utilize a very specific instance type. Let's say I want to use A1.2 extra large. So that's what I am utilizing here for running my machine. So this is A1 is my ARM based architecture. It will give me 8 CPU, 16 GB of RAM, up to 10 gigabit of network performance. Maybe this is a good enough instance for me, so I could go ahead and keep it, or I could change it to a smaller one depending on the use case I have. Shouldn't be a problem at all. All right, so I hope everyone is following along. Very basic stuff. And then I would be selecting some additional things. We will talk about key pair, like Jamila would talk about key pairs. She would explain you the benefit of having a key pair and how to associate it. Some network setting, like we talked about VPC, we could have selected a VPC and a subnet and a security group, and maybe I want to allow HTTP traffic from internet. That is what my security group setting is. We will discuss that. Let me check a question here. If we choose ARM based AMI, does that mean we need to use instance type which has a G feature in them? Yes, we would need that because the drivers in that AMI are fine tuned for ARM based architecture, and it may not be having your infrastructure driver for your Intel and AMD based hardware, right? So that's how you should select ARM based. If you're selecting, the AMI should also match what you have actually selected. It won't work in vice versa, right? So it won't allow you to select it, right? Question from in-memory GB and GIB, GIB. So the way we measure these things is little different. Like, so when we consider that what is 1 kilobyte, let me try to write it down so it would be easy for uh, we will discuss about that. Give me a minute, please. Uh, give me a minute. And we got it here. And what we are trying to do here, that we want to perform, let's say, HTTP based traffic here. Give me a minute. My pen color is different. I have to fix that. Yeah, it should be work. Now, when we say 1 KB, one school of thought says 1 KB is 1000 bytes, right? And another school of thought, the calculation wise says 1 KB equals to 1024 bytes. So this is little different way of measuring things, right? Like if I talk about how we measure liquid, so in some cases we measure liquid in liters, right? In some places you would be measuring them into a pint, or you would be measuring them into a gallon. So this is how the different units are there, and that's exactly is happening here too. So you would be having this kind of 1000 bytes and 1024 bytes, and once you are ready, you would be, that is the difference between GB and GIB. Check on internet, you would find exact detail that how much is in one GIB, but I gave you the idea that it is a difference between how we pursue 1 KB or 1000 KB. So you should be able to see that differences on that. Right. Thanks, Raghavendra, for sharing that. So please, thanks for sharing. Let me quickly show it here. It's a big answer, but it is in chat. So pick it up, put it on Notepad, and then start reading that. So yeah, that is the same thing, how we implement into 2 to the power 30 or 1 to the power 10. Okay, so we could select all these things. We could provide the storage, and we will put advanced details here. In advanced detail, I could be adding some more information about launching this, and Jamila would be covering this further. So I won't go ahead and launch it, but I had just given you basic idea, and you would be able to see this thing in action when Jamila is going with the hands-on approach, right? So I hope this thing is clear. What I want to discuss here is different instance types. Instance types are allowing you to launch your performance basic characteristics. Right. So what we are seeing here, m5.d.extra large, this is an instance type. The first letter here represents the instance family. Like I can identify that what this particular instance is. M, anyone knows what M stands for here? What is m5.d? What is representation of M here? What it is called M for? What is M for? M type of instances, what they are good for. Anyone? Memory, that is a common misconception. It is multi-purpose. I don't know why they have made confusions here. So this is your multi-purpose instance type. Memory optimized are referred as R. So I call it RAM. In the documentation, they will call it memory optimized. So instances starting with R, they are memory optimized. Starting with M is a multi-purpose, which is a good combination of CPU and memory. If it is starting with C, it would be considering your CPU and CPU optimized instances. If it is starting with G, it would be having your graphics processing unit. So these are some instance type, and you can find a lot of information about different instance types. And we keep on launching instances. Like we have i3 instances, which are giving you the bare metal hardware to run your own operating system. Right. So hopefully this thing is clear that how these instances are. And in these instances, you would also find some additional information, like you see this last letter, D. D shows additional capability, and M here shows the instant generation. So 4, 5, 6, this could be the thing. More the number, that is better performing instance. So M6D dot extra large, M5D dot extra large, these are the instance type. Here, D, the second letter which we have here, is representing additional disk capability. Similarly, you may have something which has a network capabilities on that. So additional network capabilities associated with that. So those will be displayed to you into your instance type. Let me quickly go to console to show you how it actually looks on that. Why I don't recommend using T-based instances for production? I'll answer that question. Good question. I'll explain you the question on that. Right. So this question is there. I'll explain that in a minute. Uh, Now, what is happening here that when I'm going to different instance types, I would be selecting them depending on what my use cases are. Right. So we can select the instance type, and it will take little time to load because it's a huge list of 600 plus instances. And then you would be able to see these type of things, very low network performance, moderate performance, and all additional details on that. So let's say I select instance M5 dot extra large. What is M5 dot extra large? It has 4 CPU, x86 and 64 architecture, 16 GB of RAM, and see this, up to 10 gigabit, 0.192 for USD, 0.376 USD per hour. And let me go ahead and search for a specific instance type. Right. So we may utilize any of them like C5A, and this is, see this A here. This one has a AMD based processor in that. right? And if you see this thing here, it tells you that, hey, it would be running on a Nitro type of hypervisor. It will be giving you 24 extra large and more detail about how much is the compute capacity, is free tier available or not, is it a bare metal or not, how many valid cores can be there. These all information will be displayed on that. So every instance type will be available for you to verify. Could go here and identify that information on that. I'm interested in, let's say, C5n dot extra large. What is this n? N here represents that, see this, see the difference? Up to 25 gigabits. So it is giving you additional information or additional processing power for your networking workload. And similarly, I could find, let's say, something called C5.D or C5, sorry, dot D or A or N. N is not there in C5, sorry, C5N, see this one, or C5A, and if it is, so then some of them may have some additional capability. See this, two capabilities, AMD and disk associated with that. So if I'm selecting this instance type, what it has a local storage associated which may be required for some of the processing on that, so you could utilize it, right? So should not be a problem, right? Now U6T11 metal M6A extra large, that instance type, Hari Prasad, this one is a new instance type. What we allow customers to use something called metal instances. Metal instances is when customers want to run their own hypervisor. They want, give me control of the hardware directly and I would push my own operating system on that, like VMware. So when you are running a VMware workload on AWS, we allow you to run VMware software on our physical hardware. Those are all your metal instances, because that time your hypervisor or operating system needs full control of your hardware. So that are called metal instances. So metal instances would be giving you that kind of access. You would utilize it, right? Now, let me quickly answer some questions here. Why Amazon doesn't recommend using T-based instances for production? T is a typical instance. This is not a guaranteed instance, Shetan. What happens here in this case, if I draw that, give me a minute. So in case of T instances, consider that this is a hypervisor behind the scene. This is my system, let's say Nitro system. T instances are not giving you a dedicated kind of performance. They give you something called burstable performance. Means if you say I need one CPU, we would give you one CPU, but that one CPU may not be available 100% to you. A baseline performance may be, baseline you are having, let's say, 50% of that CPU capability, and in some cases you could burst up to 100, come back and maintain your baseline. So let's say this is your 50% capacity, 100%. So most of the time you would run here and you will burst and come back to base, burst and come back to base. So this is not predicting the performance you are expecting, because this one probably is running on a system where a lot of machines running, keeping the cost low, and maybe it may happen that one instance is using more, one instance is using less, and that's why they are not recommended for production, because they do not give you a consistent state of performance. So that is what we mean by a EC2 T2 not to be used for production system, right? So that is a one way. Hopefully that answers your question. And so question from Pawan is, can we use M-based AMI for database servers? Pawan, you could use whatever you want. We don't stop you from installing whatever you want to. But is it more optimized for database workload? Probably yes, probably not. Sometime, even if I'm running database, it may not require that much of processing power or that much of memory. So it depends, what you are utilizing will be depending on your use case. And M can work for database server, I'm not denying it, but best would be you launch it on M, check and verify whether you are getting the most utilization or not, otherwise change it. And we have, if you are launching RDS databases, then we would be utilizing a specific DB instance type which are fine-tunedly created for database server. So that would be difference, right? Okay, question says, so many times AWS says certified. How a user can validate or just trust them? You have to trust them, Ranga, right? There is a process of verification and validation. It's not like I just publish something and it gets verified. So it would have to be verified. Let's say when you are downloading an app from App Store or from your Google Play Store, Google, Apple, they verify when some product is uploaded on them, right? Apple has very stringent requirement that application you are submitting to be made available on marketplace, it has to be verified by them for any type of vulnerability, any time of personal information gathering and all. So that would depend on it, and if we trust them, right? We download an app, and if it is verified, we trust them. So yes, we would need to trust them in this particular case, right? Question from Junior. For migration, the EC2 instances are selected automatically by a tool, or the analysis of which EC2 chooses manual? It depends, Junior. I would say you decide if the depends on the tool. So if you are using something called migration evaluator, it would tell you that, hey, on-prem you have a server with 4 CPU, and when you are migrating it to cloud, based on what you use on regular basis, we recommend, let's say, C4 instances to you. So tool can decide, it will depend on the tool. AWS migration tool allows you to select, or to gives you a suggestion to select which instance type will well suit your workload. So yes, that would be there. Question from Asna. To change the instance type of running instance by terminating it, uh, I won't say terminate. I would say shut down and then change the instance type. So it should be into power off state if you want to change something on that. So power off is required. You can't change type of instance while it is running. So that won't be there. Hi. And thanks, Parna, for answering question. And launch a new one by mapping the volume. Yes. Question is, instant type can be changed after stopping it. Yes, that is exactly what I said. And then uh, migration will be initiated based on what requirement? This question is not very clear. Migration in the sense, Mahi, could be, I'm running 100 machines on-prem, and now I don't want to continue. I want to move them to cloud. So what will happen in this particular case? Let me explain that. So you could use some tools, and those tools would monitor your information that, okay, you have 4 CPU, but you use only 20% of that capacity. And in terms of memory, you have 16 GB of RAM, and you use only 30% of that. So this data would be collected. You could select the gathering environment or gathering time period. I want to decide based on 7 days of collected data, or 14 days, or 30 days. And then based on the data collected, we would identify that what would be the best suitable instance for you in AWS. Will it be T2.micro, or will it be C5, or will it be M5? So that will be the data collected used as the basis to launch your instances, right? I hope everyone is clear on that. Any questions, any doubts, any confusions here? Okay, good. So hopefully this has given you a little more idea, and you will get to see more into the into the hands-on. So Jamila would go through this process and would launch an instance, and will tell you how to connect and verify the details on that. So I hopefully this was clear. Now I could not cover all the pricing options, but probably we covered it into previous videos. So check previous videos on YouTube, and you should find a good way to identify that how all these things will be priced, right? So let's go ahead and put a 5-minute timer. I hope 5 minutes is good enough. And once we return, we will then go through the through the VPC kind of component, networking component, and then we will go ahead and discuss more interesting stuff. So I hope everyone is enjoying. Enjoy your 5-minute break. I can see Abhijit also joined us. Hey Abhijit, and keep your questions coming after 5 minutes, and we will then be happy to respond. Okay, enjoy your break. Talk to you soon. Thank you.